Welcome to the latest episode of Star Cells and God. My name is Fuz Rana. I'm a biochemist and a Christian apologist, and I'm joined in studio today by Dr. Hugh Ross, an astronomer, a Christian apologist, and the founder of Reasons to Believe, which is the organization that sponsors this program thanks to the generous donations of viewers and listeners like you. Today, we're going to be talking about two discoveries that have implications for the Christian faith. Hugh's going to be talking about the moon-forming collision and the fine-tuning that is associated with it, revealing God's handiwork in creation. And I'm going to be talking about recent work regarding Neanderthal brains. Were Neanderthals like us, or are humans unique in bearing God's image? You don't want to miss it. Well, Hugh, good morning. Good to see you.
Good to see you too, Fuz.
Yeah. So, the moon is a remarkable satellite surrounding the Earth, and I don't think most people maybe fully appreciate just how amazing the moon is.
Yeah, it takes someone my age to really appreciate it, because I remember growing up as a child in the 50s and 60s. It's like, we have this moon, but there's no way to explain it. And people are saying it's got to be a miracle. Well, now we got some ways to explain it, but it's still a miracle.
Yeah.
So and I wrote about this in my book, Improbable Planet, how the solar system begins with 5 planets. You got Mercury, you got Venus, you got the Earth, and then you got this Theia, which orbits close to the Earth, and then you got Mars, and how a collision between Theia and the Earth basically explains how the moon formed, and still stands as the only possible explanation for why the moon has the characteristics it does. I mean, the moon stands out like a sore thumb compared to all the other hundreds of moons in our solar system. Where it really stands out, it's huge compared to its host planet. And it didn't form like the other moons.
Those are formed through capture.
Well, some of them are formed through capture. So a lot of the moons of Saturn and Jupiter are basically asteroids that were captured by it, and then they became moons orbiting it. Believe it or not, Earth has got a really tiny one that orbits it.
Oh, I didn't know that.
Yeah, they just found it. They don't think it's going to last long. But so that happens. But you also get moons forming out of the protoplanetary disk. So, for example, when you got Jupiter forming, there'll be a little disk around Jupiter that'll coalesce to make moons. That doesn't work well for planets that are close to the sun, because the sun's gravity interferes. And that's the thing. People are looking at it and say, okay, maybe we can get a really tiny moon. And people think that the moons of Mars might have been captured moons or captured asteroids. But they said, there's really no way. Well, they found a way. What if the solar system begins with 5 rocky planets, where one of them that's somewhere between 1 and 2 times the mass of Mars collides with the Earth early in its history, and they wind up getting a bigger Earth, a denser Earth, and you get a debris cloud around this denser Earth that coalesces and makes this gigantic moon. So that's been around for about 30 years now. And what was interesting is that to explain how the Earth got to be denser and bigger, how the moon got to have the characteristics so that advanced life would be possible on Earth, there was, I think in 2012, people were looking at this and saying, wait a minute, our explanation has way too much design in it. This is not looking like it's naturalistic. And so the British journal Nature commissioned different teams of moon-forming modelers. Please redo all your models. We got to lower this level of design we see in the models. Every one of them did that, but they came back and saying, we got a much better model. It explains a lot more details of the Earth and the moon we had before. But we're sorry, the level of design is even greater than what we started with.
And by design, what would you specifically be referring to here?
Well, the fact that you've got a big iron core in the Earth and the collision event makes it hot. And so you got this hot liquid iron core. And because the Earth and the Moon are both quite massive relative to one another and close together at the time, you basically get circulating liquid iron in the core of both bodies, which generates a magnetic field in both bodies. And because of how close they are together, the two magnetospheres merge, and that provides adequate protection to prevent the particle radiation of the early sun from sputtering away all of Earth's water and all of Earth's atmosphere. That's just one of many features that must be in place in order to allow life to exist on Earth, any kind of life, but in particular, advanced life. So that's just a little piece of it. All the details are in the Improbable Planet. But what's interesting is that in 2013, Nature had Tim Elliott basically do a review of all these restarts of the models in order to improve the models. And his comment is, all this extra design that we've now are stuck with is causing us philosophical disquiet, which is why I'm kind of titling this thing, Theia Collision generates even more philosophical disquiet, because in the last few months, 4 papers have been published basically showing, hey, there's a lot of design that we missed. And it was generated by what was called a problem of the Theia-Earth collision event that led to the formation of the moon. And the problem's been in the scientific literature for, about a decade. And it's the fact that the Earth's mantle seems to have the same composition as the moon's mantle. And it's like, this doesn't seem to fit because you would expect that, as planets form at different distances from the sun, they're going to have different compositions. And people speculate, well, maybe Theia was very close to the Earth's orbit. And it would have to be reasonably close for a collision to actually happen. So that's reasonable, but they're saying, hey, to explain how identical the compositions are, you really have to have Theia in the same orbit as the Earth. And if that's the case, you're going to get a collision before either planet is fully formed. So they said that's a problem. And it was Richard Goddard. He's an astrophysicist. I was actually at Caltech at the same time. We're both postdocs there. He said, well, what if we have Theia at one of the Lagrange points in Earth's orbit? And then maybe it could be stable long enough, because we know the collision happened between 50 and 90 million years after the Earth formed. And so he suggested, hey, we got Theia at one of the Lagrange points of Earth's orbit. Maybe it could survive that long. But papers have been published saying 50 million years is a long time for a planet that massive to remain without contact with the Earth. And so they said, this doesn't seem to be working. Well, what's happened is a series of papers have been published saying, we think we can resolve the compositional similarity problem. And basically they're pointing out with these new models of how Theia collided with the Earth is that you got Theia with a metallic core, basically an iron, nickel, cobalt core, and that with the collision, that core passes rapidly through Earth's mantle and merges with Earth's core. And so they're saying, and it comes in intact. It doesn't break up. It basically goes through. Well, it may break up in little pieces, but none of the pieces mix with the silicate in the core. And so you get this rapid merging of Theia's iron core and Earth's iron core. And that's actually a design feature. You need a big, hot iron core in the Earth. And there's one way for a planet as small as Earth to wind up with such a huge metallic core. You got virtually 100% of Theia's iron core merging with it. So, but what I think really solved the compositional problem, they realized, okay, Theia being smaller than the Earth, its mantle will have a denser composition than Earth. But the densest components in Theia's mantle are going to be able to pass through Earth's mantle and basically stop at the core mantle boundary and form what are called these large low-velocity provinces that geophysicists have been studying for 50 years. It's kind of an anomaly. At the core mantle boundary, we see these huge provinces. They're the biggest structures in the lower mantle of the Earth, and they reside right on top of the core of the Earth. And they're also recognized they're stable. And we call them low velocity because when you send seismic waves through the Earth to study the interior of the Earth, it's the low velocity ones that basically reveal these provinces. But 3 papers have been published basically saying, hey, we can explain these low velocity, large low velocity provinces by the heavy, dense parts of Theia's mantle going through Earth's mantle and basically stopping at the core mantle boundary. And also explains another anomaly, because what we see is that the liquid core of the Earth, it's got a thin layer at the very top of the liquid core that is stable. And it's got a density and a composition that's different from both the rest of the core of the Earth and from the mantle of the Earth. And then a couple of papers have been published saying, hey, if this is passing from Theia, basically these things, because they have a denser composition and are large, are capable of remaining in a stable configuration for 4.5 billion years. Because people were mystified. Hey, if you're going to blame Theia for these things, how can it possibly remain in a stable structure at the top? There's a lot of convection in the mantle of the Earth. So people were disputing this. But they're saying, given how big these provinces are and how dense they are and how compositionally distinct they are, we can actually explain how they could be stable for 4.5 billion years.
Do these low velocity provinces provide any benefit for life on Earth?
They definitely do.
I figured that was going to be the answer.
That's coming. They definitely do.
Okay, then I'll hold off then.
If you didn't have those, you need 2 things. You need that thin, distinct layer at the top of Earth's metallic core, and you also need these large, low-velocity provinces in order to explain the evolutionary history of Earth's thermal history, its magnetic history, its chemical history, and its tectonic history. Because you need all 4 of those to be stable for 4+ billion years in order to have advanced life on planet Earth. So if you don't have these 2 features, we wouldn't be here, Fuz.
Yeah.
So hey, when Thanksgiving Day comes along, you can join your family in prayer and thank them for these large, low-velocity provinces at the bottom of Earth's mantle and that thin little layer that's at the top of Earth's liquid core. And I'll explain briefly how that plays such a crucial role. But bottom line is that the Theia colliding event, explains these 2 unique features in the interior of Earth. And also the fact that you've got these dense chunks of, Theia's core or Theia's mantle coming through and forming these LLVPs, also at the same time drives a lot of the lighter metals in the mantle of the Earth into the core of the Earth. And this is something I wrote about in Improbable Planet, is what's unusual about Earth's core. It's got a lot of oxygen, it's got a lot of silicon, it's got magnesium and, phosphorus. And these metals, because they're lighter than the iron and the nickel and the cobalt and uranium and everything else in the core, they basically rise to the top and go into the mantle, and they drive the convection in the mantle. They also drive convection in the liquid iron core, because the moon is too far away now to really play a significant role in circulating the liquid iron in Earth's core. And maybe to back up a little bit, Earth's core today is not totally liquid. It was when Theia collided with the Earth. But because of the past 4.5 billion years, the core of the Earth is cooled. So now we have a solid inner core surrounded by a liquid core. But what circulates the iron in that liquid core is largely driven by the diffusion of these light metals from the inner core going through the outer core and into the mantle. But we now know what explains the abundance of these light metals is the collision event. So now we recognize, hey, if it wasn't for Theia colliding with the Earth, we would have some really significant issues here. You wouldn't have those light metals at the abundance level you need to maintain the circulation in the liquid iron core. And you wouldn't have, the thermal history. The fact that you got that little thin layer at the top of the liquid iron core and these large velocity low velocity provinces at just above the core mantle boundary, you wouldn't be able to maintain Earth's magnetic field for 4 billion years, and you wouldn't be able to maintain the tectonic activity. A miracle of the Earth, we've had strong plate tectonic activity persisting for the past 3.8 billion years. Interestingly, life plays a role in maintaining that, but the tectonics also plays a role in sustaining the life. So we got a lot more reasons to thank God for Theia colliding with the Earth at just the right time, where both bodies started off at just the right size and the just right composition.
Yeah.
This is one of the most exciting things I've read in the scientific literature in the past few months.
When I started with Reasons to Believe, I remember as part of the design parameters was the Earth, the moon, the large moon. And there was an understanding that it was formed through this collision event with Theia. But I don't think there was the recognition, as you're pointing out, of all these other just right things that had to be associated with the collision and all these just right features of the Earth that resulted beyond just simply the formation of the moon.
Yeah, what's new in the past few months, Fuz, is that we now realize Theia gets most of the credit for this unusual interior structure of the Earth. How you got the crust, you got the asthenosphere, you got the lower mantle, upper mantle, the lower mantle. Then you got these three distinct layers in the core, this upper layer, the liquid core, and the inner core. It's like that didn't happen all on its own. It took Theia colliding with the Earth to give Earth that unique interior structure. And without that unique interior structure, we wouldn't be having this podcast today. There would be no advanced life on the planet. Our planet would have gone sterile billions of years ago.
Yeah, it's just remarkable to see how, the more that we uncover,
the more we learn about Theia, and this is all driven by what they thought was a problem with the model. How do we explain why Earth's mantle and the moon's mantle are compositionally identical? Well, the mantle material basically is the same as what you see in primitive meteorites. And the fact that what we see with the Theia collision event, the collision basically differentiates between the different compositions of Theia. The core goes immediately into Earth's core, and the denser parts of its mantle go to the bottom of Earth's mantle, and which means that the material that are left would be identical regardless of where the initial orbit of Theia was. You don't have to have Theia sharing the same orbit of the Earth. It needs to be relatively close, but it doesn't have to be in the same orbit. And so that problem has been resolved. But what I love about it, in solving that problem, we uncovered a whole lot of design that we would have never uncovered if it wasn't for the fact that, hey, we got a problem with this model, and this is difficult to solve. And it took, 10 years to solve it? So, but look what happened.
So, it's amazing.
So I hope you can see I'm pretty excited about this.
Yes, I can tell.
Well, let's go from the large to the small, okay?
Yeah. Well, Hugh, I don't know if you are familiar with this TV show. I don't know if it broadcast in Canada, but in the 1950s through the 1970s, there was a show on TV network TV called To Tell the Truth.
I remember that show.
Okay. Yeah. So you had you had a celebrity panel and you had three contestants. Two were imposters. One was the real person who had an unusual profession or an unusual story. And the celebrity panel interrogated
I've watched those shows, Fuzz.
the contestants, right? And then at the end, the big reveal was who was the actual person.
And the first person to stand up wasn't really the person.
Yeah. But the line was, will the real,
Right.
Hugh Ross please stand up, right?
Right.
And well, there's a bit of a to tell the truth game that anthropologists are playing when it comes to the identity of Neanderthals, where they really would love to have the real Neanderthal stand up, right? And, there are some anthropologists who argue Neanderthals were cognitively inferior to us, that they weren't like us, and that this was part of why they went extinct. Others are saying, well, Neanderthals were just like us. Their behavioral capacities and their intelligence was on par with ours. And, this is an active debate that takes place among anthropologists. And one of the pieces of evidence that people will cite for the fact that Neanderthals were cognitively inferior to humans is the differences in the brain shape and brain volumes. And recently, a research team from the U.S. and China published a paper in the Proceedings of the National Academy of Sciences where they argued that when you compare the difference between human and Neanderthal brains as determined in these previous studies with the variation that you see in two human populations, Chinese and U.S., that the order of magnitude or the extent of the volume differences is accommodated by variation in human populations. And therefore, there really isn't any basis to argue.
Yeah, I saw that paper.
Yeah, cognitive differences, right.
Yeah, it's true. Amongst us human beings, there are people who have a brain volume that's twice that of another human being.
Yeah.
And yet there's not a whole lot of cognitive distinction between them.
Right.
So volume isn't everything.
Yeah. Well, in this particular study seemingly undermines, one of the key pieces of evidence that Neanderthals were cognitively inferior to humans. And of course, that has bearing on our human origins model because we take what I would call a traditional biblical view that Adam and Eve were real people that were created by God in his image and that all humanity comes from a primordial couple. And that the Neanderthals and other hominins were creatures that God made that existed and went extinct, that they were behaviorally and biologically different from us. And so we would expect them to be cognitively inferior because they would lack the image of God, whereas only Adam and Eve and their descendants would have God's image. And so I took a look at this paper that was published, and what they were doing is responding to a paper published in 2018 by a Japanese team that did what they called computational neuroanatomy. They took 4 Neanderthal specimens, 4 modern human specimens that were, the Neanderthal specimens dated between, I think, about 40 and 70,000 years ago. The modern human specimens about 30 to 120,000 years ago. And they did essentially CT scans of the skulls and then reconstructed the brains and then used computational techniques to estimate different regions of the brain's volumes and then compared them. And they saw statistically significant differences between the cerebellum of modern humans, which was larger than that of Neanderthals. And given what the cerebellum is responsible for, they argued that, this is evidence that Neanderthals are cognitively inferior to modern humans. So this research team comes along and says, interesting study, but they didn't compare the differences to modern human populations. And so they took samples from 200 Chinese and 200 American people.
Who were not of Chinese descent.
Not of Chinese descent, about 100 women, 100 men in each sample. And they essentially used MRI imaging to estimate brain volumes. And they said, look, the difference between the U.S. population on average and the Chinese population on average is essentially the type of difference that you see between the Neanderthal specimens and
Right.
the modern human specimens. And so the devil is in the details, so to speak, because I'm not completely convinced that the study actually undermines the fact that humans and Neanderthals are cognitively distinct, and that I'm not sure that what they did actually has bearing on the original study done by the Japanese researchers.
Didn't they look at anything besides brain volume?
That was essentially it.
That was the problem. Yeah.
They looked at brain volume, and implied in that it would be brain shape. But the
Another
problem.
question, Fuzz, did they even look at the fact that the two halves of the cerebellum? Because I've heard you mention that
Yes,
with
that-
humans, they're roughly equal.
In the Neanderthals, there's a lateral difference.
And so did they acknowledge that?
They did, and I don't think they addressed that in their study.
Mm-hmm.
But to me, the problem is that what you're looking at here is an apples to oranges comparison. Because what you're doing is, in the original study published by the Japanese researchers, you're comparing two different species, and you're looking at the brain differences in those two species versus looking at interspecies differences. And so you have to be really careful. And in fact, if you look at the table of data that they've published, where you see the differences in the human populations is different than where you see the differences between humans and Neanderthals. So I don't think that this discrepancy that they're seeing is any way, shape, or form applicable to what you see when you're comparing Neanderthals and humans.
Right.
For that very reason. But in addition to that, they also the Japanese study was comparing modern humans who were in effect coexisting with Neanderthals versus this study, which is comparing contemporary humans with contemporary humans. And in that time, modern humans were regional, were a regional population. They really hadn't spread around the world.
Right.
And so we now have, humans spreading around the world, that there are regional differences that emerge because of differences in geography and isolation, differences in the environment, things like that. But when you look at the fossil record, there's not a big difference that you see in humans, even early on when they migrate. That difference in regional populations only emerges later on, more recently. So what they're doing here, again, is an apples to oranges comparison. They're not really comparing two things. And in fact, there was another study published just recently by a team of Japanese researchers that were looking at the differences in the facial and skull anatomy of Japanese people in the early 1900s. They had about close to 100 samples, roughly 50-50 men and women. And just because of certain Japanese practices, they were able to do post-mortem analysis of the skulls and the faces. And then they took samples, post-mortem samples from about 100 Japanese, about 50 men and women that died between 2022 and 2024. And they saw that the face and the skull shape had changed.
Yes.
And they actually saw that there's a greater difference in skull shape and facial shape between men and women now than there was 100 years ago. So the point is that in this study where you're comparing U.S. and Chinese populations, you're doing contemporary people where, you very well could have the influence of sexual dimorphism in that data set. We know that there are changes that are happening between populations in
and you got a diet change.
Yeah, and dietary changes, all these things can influence that. But again, where you're seeing differences in the brain shapes or the brain volumes are different in the human population versus the human and Neanderthal populations. So again, it's an apples to oranges comparison. But even if you said, for the sake of argument, let's just grant that this study is valid, there's a whole bunch of other reasons to think that humans and Neanderthals are different, cognitively different. And one of them is again brain shape. And I've got a slide showing the differences in the skull of humans and Neanderthals. Neanderthals are on the left, humans are on the right. And humans have a globular skull. Neanderthals have an elongated skull. The face in Neanderthals juts outward. In humans, it's flat. And this impacts the brain shape. This is well understood because this is changing the endocranial shape, and you're going to have synchrony between the brain shape and the endocranial space. That otherwise you have problems. And in fact, there's a condition that I think we may have talked about on Star Cells and God called the Chiari type 1 condition, which is a situation where the shape of the skull in a human doesn't match the brain shape. And part of the brain then extends out of the foramen magnum, and it leads to all kinds of medical problems. And researchers believe that disease is actually caused by humans that have Neanderthal genes that are influencing skull development, which again highlights the fact that there are significant differences in the skull shape and hence the brain shape of humans and Neanderthals. And in fact, here's another figure that I'd like to show. This was published in 2003. And what people were doing is a very similar type of analysis where they were using CAT CT images of skulls of modern humans that were ancient, modern humans, but that lived 30 to 40, 50,000 years ago, and then Neanderthals, and then other hominins like Homo erectus, Homo heidelbergensis. And they did essentially a cluster analysis or a principal component analysis of the calculated endocranial volume, which they would argue is a measure of brain shape. And what you see is that modern human brains are in this upper quadrant,
right,
and everybody else is clustered, in the lower left quadrant. And you see a trend line going upward, which is basically showing same brain shape in the hominins. It just got larger in Neanderthals. And so there are other studies that just simply visual inspection would tell you there's going to be differences in brain shape. And the areas that you see the differences are areas that would impact cognitive capacities. There are more detailed studies like the one I'm just showing.
So are anatomically modern humans unique in that they have a globular shape of their brain? The others are all cylindrical?
Yeah, no other hominin has
that shape.
Has that globe shape to their skull. Now, in addition to that, I mean, there's other studies that have bearing. Like we have the genome now of Neanderthals and Denisovans and modern humans, and at least when you compare modern humans and Neanderthals, very similar gene set except for about 100 genes. And of those 100 genes that are different, a number of them are involved in neural development.
Yes.
Right? And we also see differences in gene regulation and epigenetic patterning that we can infer from the ancient DNA. And again, where you see those differences are in genes that are involved in neural development. There are the brain organoid studies that we've talked about, where you can take some of those differences in genes that are involved in neural development, and you can Neanderthalize modern human cells, induce pluripotent stem cells, and coax them to develop into brain organoids. And you see differences in the human versus the Neanderthalized brain organoids, where this indication is that the neuronal density and the quality of neurons in Neanderthals was not as good or as high, not as high with regard to density and not as good with regard to quality of neurons in Neanderthals versus modern
And
humans.
that's more important than the volume of the brain.
Exactly. It's much
I mean,
more important. And then
look at how small the brain of a crow is.
yeah,
Yet it's smarter than a chimpanzee.
yes.
So it's got the neural density.
Yep.
So
Yep. Yep. And then finally, just to bring it all to a close, there is a debate from the archaeological record as to whether or not Neanderthals were like us. But I'm deeply impressed with the fact that the trajectory of Neanderthal technology was static.
yes.
And for modern humans, we just sent another mission to the moon, right? There has to be something different between humans and Neanderthals to explain the differences in the evolution of technology.
We're the only species that engages in tensor calculus.
Yeah.
So
Yes.
you go to the zoo and you don't see that happening.
Yeah. And it's unlikely Neanderthals were engaged in tensor calculus either, right? So, yeah, but, so the whole point is that even if this study stands, and I think there's good reasons to question this study, but even if this study stands, there's a whole host of other reasons why we would think Neanderthals are cognitively inferior to modern humans. And therefore, this view of Neanderthals as lacking God's image is really a robust view. And it really drives home the point that human beings do appear to be unique and exceptional in a way that aligns with the biblical text that humans bear God's image.
Yeah, right. Well, I'm also impressed that, brain volume isn't everything.
No.
Because studies show that men have bigger brains than women. Does that mean we're smarter than women? No, there's other factors that bring to bear.
Yeah.
So, and there is quite a, range of brain volumes amongst us humans.
Yeah.
We need to be careful not to give that too much credit.
Right. Yeah. But even then, I think when you are doing a species to species comparison and you're comparing averages, I think that is a legitimate comparison, particularly when you produce statistically significant results for, again, certain brain regions. I think the original study done in 2018 still has merit. I don't think their conclusion is undermined by this recent study.
Very good, Fuz.
Yeah. Thank you so much for joining us for this episode of Star Cells and God. We really want you to take part in the discussion in the comments below. Let us know what you think, what your perspective is. We don't have time to respond to the comments, but we read every one of them, and we really enjoy your perspective. Also, make sure you go to our YouTube channel, Reasons to Believe, subscribe. Also, use the notification button so you're alerted when the next episode of Star Cells and God drops, which is every Wednesday. And also, make sure that you share this video with a friend. Remember, the more that we know about science, the more that we have reasons to believe in the triune God of the Bible.